you for the introduction, and thank you for coming to this session. I know it has been a long day. So my name is Tony Ng. I work at eBay in the platform organization. So I manage what we call data services, which is really a portfolio of data-centric platforms in the personalization, user analytics, and some of the machine learning aspect as well. Okay. So the topics of my talk today is really about real-time analytics. It is increasingly kind of a trend you see in many companies, right? Trying to really analyze data, doing data stream processing, right? And in this talk, I also want to talk a little bit more about how we are leveraging some of the real-time analytics aspect to enhance our personalization of our commerce, okay? Let's go. And I will also give some description around some of the architecture and platforms behind our real-time analytics and personalization as well. So just to give some context around eBay, right? So eBay actually is a 20-year-old company, right? So we have one of the largest marketplaces in the world, right? So just to give some of the stats around eBay, right? We have over 150 million active buyers, right? And around 25 million sellers, right? On eBay. And in terms of listings, right, so we have over 800 million. At any given time, there's over 800 million items being sold on eBay, right? So there's a bit of a saying, if you really want something, you probably can find it on eBay, right? And every week, we add around 8 million new listings as well. So there's a lot of new items coming up all the time, right? And we also pretty active in the mobile areas. I think eBay has been one of the leaders, right? When mobile is not super popular yet, at that time, we already invest a lot in the mobile development. So as you can see, a lot of our business is now kind of being conducted on mobile as well. Okay. So what do I mean when I say connected commerce, right? So actually one of the main purpose for eBay, right, is really try to connect all the buyers and all the sellers, right, in the world together, and doing it in a way to create opportunities for everyone, right? So that's really kind of the goal of eBay. And we actually have a very vibrant ecosystems at eBay. Right, there's a lot of transactions going on eBay. So for example, every 5 seconds, a handbag would get sold, right, on eBay, right, in US. And every minute, you would have a pair of shoes being bought, right, in Australia. And actually, for even for automobiles, right, for cars, right, every 10 minutes, a car will be sold, right, in Germany, which is pretty interesting to me when I first joined eBay. We also a very global company, right? We operated in many different countries, right? And even in the countries where we don't have a direct presence, there are actually a lot of buyers and sellers who are interested in doing cross-border trading, right? So they want to buy something from another country, or they want to sell to, customer in another parts of the world. They would come to eBay to do that, right? And we have over, when we look at our customer base, right, we see actually people coming from over close to 200 different countries, doing buying and selling on eBay. Now, obviously, when I say there's so many people, conducting their transaction on eBay, right? So there's just going to be a lot of activities that are generated, right, as the different users are interacting on eBay, right? So they may be doing searches, they may be adding some items to their shopping cart, they're doing checkout, etc., right? So all these user activities are generating a tremendous volumes of events, right, that we want to collect and analyze over all this data, right? And just to give you a sense of the kind of volumes we are talking about, right? In terms of database query, right? On every single day, we typically would do around 10 billions different database queries, right? As we kind of serve the requests of the users. And on a given day, typically we would generate around 8 to 10 billions user activities events, right? Which would be translated into around 10 terabytes of data, right? And altogether, at least, around this time, we are storing over 100 petabytes of data for the users, okay? So there's a lot of data, right? But I guess the challenge there is really how you can take advantage of this, right? So having all this raw data is not that useful if you cannot really translate that into, insights that you can really act on, okay? So I guess, back to what I mentioned about the connected commerce, right? So one of the main challenges for eBay is with so many different items on eBay, right? Around 800 million items, right? How do you actually service the right sets of items to the potential buyers, right? So that's one of the challenges. We have far more products on sale on eBay compared to a typical e-commerce retailers, right? Now, traditionally, we try to do this, the model that we try to do this is people would come, they would do search on eBay, right? So we spend a lot of time improving our searches, right? Now, that's one way, right? But what we believe is that only really represents one part of the user base, right? Which is, someone really want to buy something at that moment, right? Like, okay, I have a need to get a battery for my mobile phone, for example, right? But what we find is over time, right, we want to augment that model with more of an engagement model, right? So perhaps, the user coming to eBay is not really at that moment want to buy something, right? But he or she is really kind of very interested in shopping, right? And they just want to come and do some browsing, right? And maybe if eBay can actually service some items which are, kind of fit their passion, right? If we understand what our users are passionate about, we can inspire the users, right? And we can show them the things that they care about. That could actually translate into a sales, right? And make eBay actually more of an engaging place that perhaps people will just come and they browse and check out what is some cool stuff they can look at or potentially buy, right? So that is really one of our goals of doing more of personalization, right? Is that you don't need to wait for the users to come to search, right? You are kind of based on the user profiles and based on their past behavior, we would be able to service something to them to make our experience more engaging and inspirational. Okay. So, to do that, there's actually a couple of challenges there, right? So first of all, as a users, right, I'm not only focusing on one thing, right? I might have many different interests, many different intents, right? And actually, it's actually important to distinguish between what we call intents versus interests, right? So to us, intent is really more of at the moment, right? At this particular moment, I have a need to buy something, right? It's kind of more short-term, right? More recent kind of thinking, right? Interest is really more longer-term kind of passion, right? Kind of maybe I'm an outdoor person, right? It just happens that right now I need to buy a battery, right? But my interest is really more about outdoors, right? So how do you kind of try to balance multiple kinds of interests and intent of a user, right? Identity is also a challenge, right? So because as an e-commerce site, you usually do not require the user to sign in, right, until they actually decide to buy something, to check out something, right? So without someone signing in, it becomes a bit of a challenge to identify, the visitors, right? And how do you know, like to personalize, you really need to know the person, right? And there's a bit of a challenge how to associate someone who has not signed in to eBay with the actual people, right? Multi-device, multi-screen is sort of related to identity as well, right? So people now, they might be using a mobile phone and then they switch to laptop, right? Multiple times as they go through their transaction. And again, if they are not signed in, right, it will become a challenge. How you can try to identify that someone coming from multiple devices are actually the same person, right? I already mentioned about data volume, right? So our system has to be very scalable in order to deal with the data volume, as well as how we can derive insights from it, okay? And the last aspect is about the freshness, right? So traditionally, I would say a lot of the personalization is typically done around more of a historical data, right? So you try to determine the profile of a user, right? And then you use that to try to personalize, right? But what we believe is that it's actually useful to, it's still important to look at the longer-term historical data, but sometimes it's useful to try to combine that with more of the recent activities of the users, right? And that data freshness becomes important if you want to be able to look at the most recent activities of the user. It's no longer good enough to wait for the next day to kind of find out what the user have done, right? Because by that time, the user may have left already, right? So if we look at the technologies building blocks for personalization, right? So there's a few areas, right? So first is all around the data, obviously, right? How we are collecting the data, right? And how you can access to the data that you would need in order to do your personalization, right? I'll talk more about it later. There's different way to access the data, right? Ranging from batch model to real-time model, right? So in this talk, I will focus a little bit more around how we are doing the real-time, because I think the batch model is better understood in terms of how you access the data. Now, now that you have all the raw data, right, the next thing you have to do is, figuring out how to do some machine learning, right? A lot of companies may be starting using rules, right? So before machine learning come along, a lot of personalization is based on rules, right? So you might decide some rules saying if someone is a female under 25 years old, maybe you personalize the site this way, right? But more and more, right, that's not quite sufficient, right? So we need to leverage machine learning to discover more of the correlations among all the data, right? Try to derive insights that maybe a human cannot really easily see before, right? So we have used different tools to do machine learning, ranging from interactive analysis as well as different algorithms that we use, right? And then the last part is around the prediction aspect, right? So you might have the machine learning model done by your data science team, but then ultimately you need to have a systems that can, at real time or in batch, right, try to do the actual prediction, right, based on what you have learned through the machine learning, right? And all this system has to run on a very scalable platform. You need to have an elastic compute infrastructure. So we are leveraging some of the newer things like containers, Kubernetes, right? Some of this to make it much more flexible for us to do some of this machine learning training as well as prediction. So from a data point of view, there are different kinds of data that we look at. Just as examples, we look at user profile data. I think that's kind of more of the typical, the gender of the user, right? Some of the segmentation they have. We also look at what we call the real-time activities, right? So these are really all the activities that they are doing on our site, right? As well as what we call the context of the user, right? So this is when the user comes to eBay, are they using a mobile device, right? Are they on desktop? Also, where are they accessing eBay from, right? All this important context that we can leverage to do further personalization. And finally, we also have what we call predictive models, right? So these are actually the next level of summary, right? So you look at the profile data, you look at the real-time activities, and based on that, you can actually derive kind of more of a summary insight, right? So maybe, okay, is this person, what kind of price range is this person comfortable with, right? Do they tend to like to buy new items or used items, right? So all this, or what product categories are they interested in, right? So all of these things will be useful for us to decide how to personalize. So a little bit more on the user activities, right? So as I mentioned, the user activity actually can span a very long time span, right? So you have a user, maybe they come many times, right, over a long period of time. And what we look at is that this activity will become a continuum, right, between kind of a longer-term historical data as well as, the most recent activities, right? So generally, the historical data will be in some offline systems, and we want to leverage that and try to derive kind of more of a user profile type of data, right, based on a long range of activities, right? So this might service more of the longer-term passion and interests of the user. And then whereas for the more near recent activities, right, that would help us to make kind of more short-term decisions, right, because that would represent at the moment what the user is interested in, right? And I would kind of spend some time in terms of how we are going to manage to build this user activity timelines for every single user, right? So to do that, we kind of need to have an infrastructure for doing real-time analytics, right? And there's actually quite a bit of requirements around, right, to be able to do this at scale, right? You need to have an infrastructure, right, where you can actually scale to dealing with millions of events coming in, because that's the amount of activities that you'll be dealing with, right, in a large e-commerce sites. We want to be able to make very fast decisions. So we want to be able to ingest this kind of activity data and be able to make decision within seconds, right? Not like the next day, right? We want it to be highly available, right? And also very flexible, because there could be different logic that we want to put in terms of doing real-time analysis. So we want to make it easy to implement this kind of logics, as well as changing the actual logic for the customer. So, with the requirements that, we have, right, we look at some of the kind of open source technology out there, and we actually couldn't quite find something that meets all of these requirements. So we end up actually kind of build something of our own, right? We did open source this technology back in February, so, I'll give you information at the end, and you can check that out. So what Pulsar really is, it is open source real-time analytics frameworks and stream processing frameworks that we use at eBay to do some of this analytics at real time, okay? So conceptually, you might ask, what is really real-time analytics, right? And what is stream processing, right? So really think of it as you have different data streams coming in, right, represented, kind of on the left-hand side. And as this data stream come in, right, it's kind of flow through this data pipeline, right, which really consists of different processors connected together in a graph, right? The blue square kind of represent the processors, right? And processor can actually do different kinds of computation or transformation, right? And you can kind of wire all this stuff together in a very flexible manner, right, to form what we call the topology, right? So important concepts here is really one, how this is different from a traditional messaging system, right? Is that one, you can actually do transformation of the data as the event coming through the system, right? And you can actually generate different data stream, right? So you have the incoming data stream, and you can actually further create substreams, right, for the specific use case, right? Because a lot of times the incoming stream will be very big, right? It consists of all the activities of all the users, right? And for your particular use case, you might not need all the data. So it's very important to have the ability to kind of create this filtering substreams so that you don't need to have to always deal with all the data, right? In-memory aggregation is also a very common operation that people would do on this, right? So many times you want to do counting, right? How many people are visiting the home page, for example? You can have different dimensions also, right? So maybe I am interested in how many people are visiting using iPhone from San Francisco, right? All these different dimension and counting, you can actually do that. If you need it real time, you can do that with this framework. Okay. So this kind of a little bit more details, right, in terms of how we can make this real-time framework more scalable and available, right? So in a typical analytics framework, you would divide your computation into different stages, right? So here I'm showing 2 different stages. And each stage is really represented as a cluster of processing nodes, right? So by having a cluster, you have the scalability and availability, right? And the framework would actually automatically partition the data into the right processing nodes, right? And that's important because when you try to do aggregation, you want to have the events from the same user to always go to the same node, right? So you can do the aggregation properly, right? We handle all the messaging between the stages, right? So you don't need to worry about that, right? And within each of the processor, right? Think of it really just as, you have an input channel, which is how the data is coming in. You can put in your processing logic, right? Which is, how you transform the data. And then you have the output channel, which is, how, where should the data go next, right? So very simple concept, but when you wire all of this together, it gives you a very flexible and powerful kind of computation concepts. And you can do so many things just with this wiring of the processing nodes together. So this actually represents the actual kind of how we process the user activities coming in from eBay, okay? So we have about 4 different stages, right, as you can see in the diagram. So 2 of the stages are quite important from an e-commerce analytics perspective. One is what we call bot detection, right? So bot detection, because there are actually a lot of, and what bot detection is really trying to distinguish between human activities and non-human activities, right? So e-commerce sites like eBay, there's actually a lot of non-human activities coming in. There are programs that try to find out all the prices, right, doing price comparison, all this stuff. So for us, we would like to be able to distinguish between a human and a non-human, because from personalization point of view, it's not very useful, actually, to try to personalize for a non-human, right? So we want to actually filter out a lot of the non-human activities to reduce our resource cost, right? The other stage is the sessionization, right? So this is pretty typical from a web scenario, is that you just want to group many different web requests of a single user, right, into one visit, right? And you typically have to do that by, figuring out when the user stop having any new requests. You wait for a period of time, right? So maybe wait for 30 seconds. If there's no more new requests from the user, you kind of know, okay, the user kind of finished the particular visit, right? And this is important because a lot of the metrics and analytics are typically based on a user visit rather than based on the individual request of the user, okay? And then from then on, we have ability to send the data streams to many different applications, right? So that is the event distributor. And then we have the metrics calculating stage, which is just doing a lot of aggregation. We are doing countings along different dimensions, right, to get the analytics of the user. And this is just another view in terms of what kind of computation you can do through these pipelines, right? You can do enrichment, which is kind of you insert additional information as the event come in, right? You can do filtering, as I mentioned, aggregations, right? As well as some of the more advanced calculation that involve, keeping track of state, right? So the good thing with a complex event processing pipeline is that you can actually keep track of state as well. So you are not limited to just looking at the event coming in at the moment. You can keep track of some history of the previous events, which enable you to do further computation. So I just want to show you some examples in terms of how you would implement some of the logic in the pipeline. Right, so we support a SQL-like syntax in our pipeline, which we find is useful because a lot of the analytics actually is quite similar to the kind of things you would do with SQL, right? So just imagine instead of operating on a database table, you're operating on a data stream, right? But a lot of the operation you can do on a database table applies to a stream as well, right? So here I'm just showing how you can do filtering, right? Using a where clause as well as a select, right? You can subset the data stream coming in. We extend the SQL syntax with some annotations. So here we show you how you can, after you have done the filtering, where you're going to send the resulting streams to, right, to a particular topic. Next example is around aggregation, right? So in SQL, how you do aggregation is using select count, right? So you can kind of do the same here with data streams. But with data stream, what you need to do is actually specify a time window, right? Because a data stream is an infinite set of data, right? So you have to specify a time windows, which is where you're doing the aggregations, right? And when the aggregation is done, it will send the results down to the next stage. Similar example here, this just shows that you can do sorting also, right? Using the order by syntax in SQL, right? Which is useful if you are interested to find out, okay, what are the top countries of the user coming in, right? So this will be useful to allow you to get that information. Now, top-end computation is actually quite expensive, from a data stream point of view, because in order to do sorting, you always have to remember all the events that had come before. So, there are some approximation algorithms actually that you can use to avoid remembering all the events, because that will be a huge memory requirements, right? Imagine keeping track of all the millions of events coming through, right? So we leverage some of the approximation algorithms to help reduce the amount of memory requirements to do top end. So besides personalization, there's actually a lot of other use cases where real-time analytics pipeline will be useful, right? So you can obviously get real-time dashboard. You can even do monitoring, right? You can get alerts, right? If the number of people doing searches is somehow below your typical metrics, even fraud detection. So there's many applications besides personalization using this pipeline. So here's just some information. If you're interested to take a look at this framework, it's open source. On GitHub, there's different documentation and so forth. Okay, so I kind of spend time talking about the data collection and processing layer, right? So now I'm going to shift a little bit of focus. Okay, how are you actually going to serve the information, right, to the user? This is when you are actually doing the personalization, right? So you kind of need a system to be able to do that, right? and again, there's different requirements. The key is, right, it has to be a system that is perform very fast and be able to handle large amount of data as well, right? It's almost think of it as a data store, right, of all the personalization information about a particular user, right, when they come. And you need to be able to get the information really fast, right, when the user visits the site. Okay. Now, as I mentioned, right, so machine learning model is increasingly being used, right, in the personalization space. Okay. So there are actually different approaches, right, when it comes to actually evaluate the machine learning models that are created by the scientists, right? So traditionally, a lot of times, these kind of models are evaluated offline, right, in the batch, right? So maybe you have some data in Hadoop, and every day you will run a Hadoop job to try to apply your machine learning model, right, to the data set, right? And then you would then store the results, right, of that model, right, into some personalization system, so you can use it at the runtime, okay? But there's actually other ways now, right? So with, one way is what I call nearline, right? So which is actually by having the real-time data stream coming in, right, you can use that to trigger the machine learning evaluation at that time, right? So rather than applying a batch job, you would have the activity to trigger the evaluation of your machine learning, right? And then you store the results again into the system, right? And finally, you can even do it at real time as well, right? So this is when, when a request actually come in to the personalization system, you would at that moment, evaluate the machine learning model, right? So the advantage, the good thing about this is you are guaranteed to leverage the freshness data, right? So you can guarantee to look at all the most recent activities, right? Whereas in an offline system, you would pretty much miss all the most recent activities, right? So this is this continuum between whether you need to look at the most recent data or you think some of those attributes will be changing very rapidly, right? On the other hand, if you have a very complex model, right, you have to run it more in an offline of nearline system, right? Because it just will be too expensive to try to run it at real time, right? So at eBay, we kind of have, we use all this actually. So we have a continuum, and depending on the model and depending on how we think how dynamic we think the information will be changing, we apply different approaches in terms of evaluating a machine learning model, right? So to support the real-time evaluation, right, so we actually have a system called Busai, right? And this kind of give you an overview of the architecture, right? So the key is that we are actually embedding the personalization data together with the machine learning evaluation, right? So we're co-locating the computation with the data as well. And that's how we can actually perform the evaluation very quickly, okay? So we have a real-time model evaluation framework in Busai, right? And as I mentioned, right, the data is actually fetched into the in-memory cache, right? And we can execute both machine learning model as well as custom rules, okay? And we are leveraging something called the PMML, right? So one of the difficulties, I think, a lot of people doing machine learning face is that when the data science scientists, right, when they create a model or they train a model, right, they tend to use the tools that they are familiar with, right? They may use R, they may use Python, they may use different things, right? But a lot of times those technology might not be appropriate to actually deploy in production, right? It's not easy to run R in production, right, with a very strict latency requirement. So then what happened is the data science team has to kind of give that model to a development team who would need to actually implement the model again, right? Maybe in Java or something, right? And that would add, months to the development cycle, right? But with PMML, what it is that it has the ability to actually describe the model in a way that is independent of the underlying language, right? In fact, a lot of the machine learning tools like R, you can actually export a PMML description of the model, right? So our runtime is able to take the PMML model and we already have implemented quite a few of the common machine learning algorithms, so we can just directly run those models without custom development work. So that we believe actually saves a lot of time. So just a little bit more about the architecture, right? So as I mentioned, you can evaluate models and rules, right? So that's the compute layer, right? And the key is we have a lot of, we are using machines with a lot of memories. So we have the in-memory cache that is partitioned by the users, right? So depending on a particular user, we would route the request to the right, memory node, right? And we fetch the data from the disk storage to the in-memory cache, right, when the user becomes active, right? So all the computation happens in memory. There's almost no I/O requirement. We don't need to fetch data from any database or from another machines. So this really helps us to be able to perform machine learning evaluation at real time, right, which is traditionally not available in other systems. So this is a bigger picture, right? So on the left-hand side is really the Busai system that I described. The key for the success of this system is that just having the model runtime is not good enough, right? You really have to make sure you are able to move a lot of data into these systems, right? So here, is where we are tying our real-time data pipeline, Pulsar, right, which we are feeding in all the user activity data, right, at real time. We put it into the queue, which would get fed into Busai, right, as well as all the offline data as well, right? So we are ingesting offline data, real-time data, as well as transactional data, right? So all of these, we put it into a queue, which would then feed into the disk storage of the Busai system, which would then in turn be made available, right, at runtime to serve the particular personalization request. Okay. So key takeaway. So I have kind of talked about real-time analytics and personalization, right? So I think both are becoming more and more a very important aspect of any e-commerce site, right? And I think, with real-time analytics, we now have the opportunity to be able to combine both very recent activities of the user with a longer-term historical profile of the user. And we believe that would kind of open up new opportunities to do a better job of personalization, right? And in order to do that, you have to have infrastructure that would enable you to leverage both offline data as well as real-time data, right? So just Hadoop is not enough, right? You need to have some form of real-time stream processing kind of infrastructure, okay? And there's also an aspect around going from more of a traditional rule-based personalization to leverage more of a machine learning, right? And to do that, again, now you need to have some infrastructure to be able to evaluate machine learning models, right? Either at real time or at more of an offline mode, right? And to be able to do all of this, right, it's important to actually have fast and scalable platforms, right? Because the amount of data is just going to increase more and more. And the time you want to be able to process the data is you want to have it like shorter and shorter, right? So being able to tap into some of the more near real-time and scalable system will become more important.